simple salts which consists of one acid radical and one basic radical. Such salts are known as simple salts. The ions of the molecules which are bounded to the central metal atom by a coordination bond, they are known as ligand. Need-ended ligand again are of three types. It will be in the neutral form or in the negative anion form, or it will be in the positive ion form. So di-dentate ligands are the ligands which have two donor atoms. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in this session, we are going to start with the new unit called Coordination Compound. So, before going to discuss with this unit, let's see the weightage of this unit. So, from this unit, we can expect totally around 6 marks and the question number will be like this. The question number 25 and 26 from this unit from the part C will be asked for 3 marks and the totally we can expect 6 marks. And it is one of the easiest unit where you can easily earn 6 out of 6 from this smallest unit. Okay. So, when we are talking with this coordination compound, we need to understand some of the inorganic salts. And in your lab also, you have studied about the different types of the inorganic salts in the salt analysis. Is it right? Yes. So, when I am talking about this inorganic salts, this is again are of 3 types. It will be named as simple salts, double salts and a coordination compound. Okay. So, it will be named as simple salts, double salts and a coordination compound. So, in this unit, we are going to learn more about this classifications of the inorganic salts. Then, we are going to understand the differences between double salts and also with the complex salts. And finally, we are going to understand some of the important terminology which are involved in a coordination compound. So, when I am talking about this inorganic salts, remember again there are of 3 types. Okay, which are those? They are double salts and single salts and also with the coordination compound, which is also known as what? Complex salts. Which is also known as what? Complex salts. So, which will be studied under the inorganic salt. So, let's see what are the simple salts first. When I am talking about the simple salts, always remember simple salts which consists of one acid radical and one basic radical. Such salts are known as simple salts. Okay. You can take the example of zinc sulfate. Here you can see that zinc is a element which are forming a positive acid radical. Similarly, the sulfate will form a basic radical. Is it right? So, in this compound, you can clearly understand there will be a one acid radical will be there and one basic radical will be there. So, which is the acid radical here? Acid radical is a sulfate and basic radical is a zinc. Okay. It forms what? Zinc sulfate. Clear? Next. When I am talking about the double salt, usually it consists of mixture of 2 simple salts. So, example here you can see that in the kernelite you have KCl magnesium chloride with 6 water molecule. You can see in this compound it is a mixture of 2 simple salts. So, you can see that the chloride is a acid radical. Similarly, the potassium and the magnesium is a basic radical, which are the 2 different salts which are present together and forming what? Double salts. When I am talking about the complex salts, what does it mean? These are the compounds in which central atoms are linked together by number of ions or with a neutral molecule by coordination bonds and donated by lone pairs of electrons by the ions or with a neutral molecule to form a central metal ion. So, in this case, which is a central metal ion? So, iron is a central metal ion which is surrounded by the Cn along with the potassium. Now, let us see what are the differences between the double salts along with the complex salt. Always remember, if I say it is double salt which is formed by what? Combinations of two simple salts. So, the double salts are stable only in the solid state but dissociated into simple ion in the completion in the solid solution state. Example, in the kernelite, I have explained that it consists of KCl, magnesium chloride along with 6 water molecules. So, the potassium and the magnesiums are the two different basic radicals which are present in it. Similarly, when I am talking about this complex salt which consists of what? Which is usually stable both in the solution state as well as in the solid state and do not dissociate it completely in the solution state. So, example, in a hexacyanoferric sulfate, and similarly you can see that potassium hexacyanoiron which is not dissociated to give iron 2 plus as well as with a Cn minus ion. So, these two are the differences between double salt with a complex salt. So, when I am discussing with this coordination compound, always we need to understand some of the important terminology which are involved in this coordination compound. So, here I have an example. You can see that this is my first example where you can see that this is a metal, central metal atom, okay, which is surrounded by different elements. So, it is surrounded by 3 chlorine atoms as well as with the 3 ammonia molecule. Here you can see that we have represented with the bracket which is known as coordination sphere, and you can see that between these two, you have a 6 bonds. They are known as coordination bond, and outside of this sphere you can see that we have represents it 3 plus. It is known as complex ion charge or the charge on the complex ion you can see. Okay, and this is my central atom surrounded by 6 different ligands. Is it right? So, these are the 6 ligands which is present. You can see that ammonia is a ligand whereas the 3 chlorine ions are also known as counter ion. They are known as what? Counter ion. This is how when whatever the compound is given to you, you have to identify the each part which are involved in that complex. Okay, one is ligand, counter ion, charge, sphere as well as with a coordination bond. Okay. Now, let us see the first definition, that is coordination entity. So, what is coordination entity? What does it mean? Let us see now. The coordinate entity or coordination entity constitutes a central metal atom or an ion bonded to the fixed number of ions or a molecule through the coordinate covalent bond. So, already I have explained that there will be a central atom, okay, surrounded by what? Fixed number of what? Ligand. Surrounded by fixed number of ligand by what? Coordinated bond. By forming what? Coordination bond with the ligand, it forms a fixed molecule that is known as coordination entity. So, here we have an example of COCl3 and NH3. So, here the compound will be written like this, that is CO is a central metal atom surrounded by 3 different chlorine. Similarly, it is surrounded by 3 different ammonia molecule, and it has how many charges? You can see that it has plus 3 charges. So, here you can see that this is a central metal atom, and this is my ligand, and you can see that this is a charge on the complex ion, and this is a coordination sphere. And you can see that these 3 chlorine atoms are nothing but a counter ion. Is it right? Counter ion. This is how whatever the compound which is given to you, you can easily identify the coordination entities which are involved in the complex. Okay. Next we have central atom. So just now we have learned that what will be the central atom and how does it forms a bond with the ligand by forming what? Coordination bond. Is it right? So metal atom or the ion is the coordination entity to which fixed number of ions of the molecules are bounded to the definite geometrical arrangement around it and forms a central atom. So already in my last example I have written the 3 different ligand with the 3 different counter ion. It should be have a specific geometry. Okay. So it should arrange in a specific geometry to form a specific structure to that central metal atom. Then only we can say it is central atom. So here again you can see that the nickel chloride water molecule, and you can see here nickel is a central metal atom in this element. Similarly, the iron is a central metal atom in the hexacyano-iron. Okay. Here you can see that how to write the structure. So here the iron is my central atom surrounded by how many cyanide ion? 6 cyanide ion. Is it right? Surrounded by 6 cyanide ion. So it is Cn. So what is the charge here? You can see that charge will be 3 minus. So iron is a central atom here. And what are these Cn? They are nothing but ligands. Okay. So what is the charge here? Minus 3 is a charge on the complex ion, and this whole bracket is a coordination sphere. Okay. Next is ligand. So while writing this structure, I have also written the ligands. Let's see what are ligands now. The ions of the molecules which are bounded to the central metal atom by a coordination bond, they are known as ligand. So what is a ligand? Ligands are nothing but molecules or the ions which are always bonded to the central metal atom by forming what? Coordination bond. So here we have the example of tetracyanonickel or nickel tetracyanate. So here which is a ligand? You can write this structure. So this is my nickel which is having how many cyanide ion? So 4 it is. So it is having tetrahedral geometry, and you can see that it having minus 2 charge. Here we know that this is my central atom and these 4 Cn are the ligands. Is it right? How does ligands will form a bond? You can see that there are 4 different ligands will be there. Is it right? They are forming the coordination bond with the central metal atom to form this complex. Is it right? Hence, this is the example for the ligand where the cyanide is a ligand and the iron is a central metal atom. Next is types of ligand. So, there are different types of the ligands will be there. So, first I will go with the first one, that is unidentate ligand. So, it is a ligand in which one donor atom will be there. That is, the ligand will bond it to the central metal atom through the single donor atom or with a single bond. For example, in a H2O or with the ammonia. So, we can see that in the ammonia, so we have the central atom, so which are bonded by 3 different hydrogen atom, and you can see that all this hydrogen atom, they form a single bond with the nitrogen. Hence, it is a unidentate ligand. It is the best example for the unidentate ligand. Similarly, you can write the structure of oxygen. Okay. So, in case of oxygen, here also you can see that the 2 hydrogen, they forms a coordinated bond with the oxygen. Hence, it is an example for the unidentate ligand, where the ligand which forms what? Single donor bond with the oxygen atom or with the nitrogen atom or with the central atom you can say. So here again in a unidentate ligand again are of 3 types. It will be in the neutral form or in the negative anion form or it will be in the positive ion form. I'll go with the neutral ligand. Okay, it is unidentate neutral ligand. Okay, so example is water molecule, ammonia, carbon monoxide, nitrogen oxide and CH3NH2 and C2H5N. which is a pyramid. So in all these elements, the unidentate ligand which carries what charge? Zero charge, because it is a neutral ligand. Similarly, you can take unidentate negative ligand. We know that all these ligands are negatively charged. Example is OH minus, F minus, Cl minus, Br minus and iodide, cyanide. All these ions are negatively charged. Hence, it carries what? -1 charge usually. Similarly, I can write the unidentate positive ion ligand. So, here you can see that nitrous oxide and nitrogen dioxide which carries plus charge. Hence, it carries +1 charge. This indicates that even though it is a unidentate ligand, either it can carry 0 charges, either it can carry the plus charges or it can carry the -1 charges. This indicates that unidentate ligand may be neutral or it may be exist in a negative form or it may exist in a positive ion form also. I'll go with the bidentate and a polydentate ligand now. So, didentate ligands are the ligands which have 2 donor atom. Example is, you can see that oxalato. Here you can see that COO minus and COO minus. In these two, you can see that there are 2 donor atoms will be there. Similarly, in case of ethylene diamide, you can see that CH2 NH2 and CH2 NH2. So, there are 2 donor atom will be there. So, this indicates that in case of this bidentate ligand, always there will be a 2 donor atom which will form a bonds with the central metal atom. I'll go with the polydentate ligand. When several donor atoms are present in a single ligand, the ligands are said to be polydentate. So, example is ethylene diamide tetraacetate ion is an important example which is also known as hexadentate ligand, and it can bind through the nitrogen atom with the 4 oxygen atom with the other rest of the central metal atom. Here you can see that this is an example for the polydentate ligand. You can see that how many ligands will be there? There are 6 ligands will be there and it has been attached with what? Central atoms called as nitrogen and forming a polydentate ligands. So, poly means what? Many. If many ligands are attached to the central metal atom, we say it is poly. Okay. Next, we will have one more ligand known as ambidentate ligand. What does it mean? The ligand which ligate through the 2 different atoms are known as ambidentate ligand. Examples are nitrogen dioxide and SCN ion. Nitrogen dioxide ion can coordinate either through the nitrogen atom or with the oxygen atom to the central metal atom. Similarly, the SCN minus iso, that is thiocyanide. You can see that here. So, which are the ligands here? You can see that here NO2 minus is a ligand. So, which can form a bond with oxygen atom, as well as you can see that it can also form a bond with metal atom also. This indicates that such kinds of ligands which are always forms 2 different atoms, when they are linked together, they forms a ambidentate ligand. So, we have one more example, that is thiocyanato and isothiocyanato. You can see that. So, here the S is bonded with the metal atom and form a thiocyanato complex. Similarly, you can see that nitrogen is bonded to the metal atom and forming what? Isothiocyanato. Here also you can see that nitrogen is bonded to the metal and forming nitrato nitrogen. Here you can see that oxygen is forming bonding with central metal atom and hence it is nitrato oxygen. This indicates that even though the ligand which consists of 2 different atoms, it can easily bind with the central metal atom, hence it is forming a ambidentate ligand. So, in this case, the NO2, N is a one atom as well as the oxygen is another atom. So, both are 2 different atoms acting like a ligand and it can bind to the central metal atom, hence their names will be different. Okay. You can take the example of HCN So in HCN also, either if it is bonded with the sulfur with the metal atom, we say it is thiocyanate. If it is bonded with the nitrogen with the central metal atom, we see it is isocyanato. Okay. Next, we have one more kind of ligand known as chelating ligand. What does it mean? Let's see now. When di or polydentate ligands uses its two or more donor atom to bind with central metal atom, it is said to be chelating ligand. So, what does it mean? So, when di or polydentate ligands are there, if it is uses the central metal atom to bind with central metal atom, such ligands are known as chelating ligands. You can see that copper is a central metal atom which is surrounded by, this is a best example for didentate ligand. Is it right? So, it is a bidentate ligand, or you can say it is didentate ligand because it is CH2NH2. Similarly, you can see that on the other side we have a bidentate ligand. So, these two bidentate ligand, they are bonded with the central metal atom. Hence, such ligands are known as what? Chelating ligand. So, what does it mean? So, remember, if I say it is chelating ligand, either bidentate ligand or polydentate ligand can attach to the central metal atom on the both the side. Such ligands are known as what? Chelating ligands. So, here I have an example of central metal atom bonded with two bidentate ligand. So, next important definition is coordination number. So, coordination number of the central metal atom or the ion is a number of the ligand donor atom to which metal atom is directly attached. So, what is the coordination number? So, coordination number means always remember there will be a one central metal atom which is surrounded by different kinds of ligands. Okay. So, that is known as coordination number. In case of monodentate ligand, coordination number will be always equal to the number of ligands. So, that is only in case of monodentate ligand. So, if coordination number is 2, then we say such geometry will be linear. The best example is AgNH3 2 plus and similarly AuCl2 minus. In both of these two examples, you can see that the coordination number will be 2 and it will be exhibited in linear geometry. Okay. Next is coordination number 4. Usually it has square planar structure and the example will be goes like this, that is palladium tetrachloropalladium 2 minus. Similarly, the tetrammonium palladium 2 plus ion is a best example. If coordination number is 4, it always exhibits in what? Tetrahedral structure and the example is tetrachlorocopper and tetraammonium zincate or with a zinc. Next, if coordination number is 6, it always exhibits in octahedral structure. Example, hexafluoro iron or iron hexafluoride you can say. Then 6-amino or hexamino cobaltate 3. This is how we usually name the compounds according to their coordination number. First, PUC also have taught that how to calculate this coordination number. Okay. So, in the next session, we are going to discuss with the coordination sphere. More about the coordination sphere we are going to discuss with next session. Till that, take care and be safe and try to work out with the important definition that we are using in coordination compound. We'll meet you with the next session. Till that, take care, be safe. Thank you.